Okay, so let's say I give you this formula. What would the name of this stuff be?
Magnesium fluoride.
Magnesium fluoride, okay? For any ionic compound, okay, we write the name of the metal and we write the name of the non-metal, okay? But we change it to N in ide, okay? Everybody all right with that? Okay. Do I need prefixes in an ionic compound's name?
No.
Okay. Do I ever put prefixes in a ionic compound's name? No. What might I put in there? Roman numerals. When would I use those?
When there's different charges for the transition metals.
Exactly. If I have a transition metal, okay, somewhere here in the middle of the chart where a number of those metals have more than one possible charge. Okay? If that's the case, then I will have to tell people which charge that is. Okay? For example, we were actually looking in CLCs on Friday at this particular compound. Did we do we didn't do the polyatomic ions, did we? Okay, we didn't get to that. All right, so we were actually looking at this compound because we had a note sent to us from Alberta Learning that said you cannot use copper sulfate in labs anymore. And we're like, we use copper 2 sulfate in labs all the time. Like, it's critical for like half of the labs. It's even going to be one of the unknown samples in the lab you guys do next week. I'm like, what do you mean we can't use that? Well, typo. They just wrote this. Kind of a big deal. It was exactly what we were talking about on Friday, right? What if this thing is really good for you and this thing is really toxic and had the same name that's not good, okay? Well, this one wasn't the one that's disallowed. This is copper 2 sulfate. That is allowed, okay? Copper 1, which I've never even seen before because it's so incredibly rare, okay? And actually looks like this, is not. Because apparently it's like an incredible irritant of the respiratory tract. It's like, great, something we never used, ever. Never even seen it in my entire life, and I'm not allowed to use it. Thanks for the memo. Okay? So yeah, it was just a perfect example, and it was just like, I taught it that morning, and we're looking at it like, what the heck is going on here? Which copper sulfate are they talking about? So, important that if a metal, like copper or iron or any of those transition metals, has more than one charge, that we put the Roman numeral in the name. If we don't, then it's wrong, okay? Because we don't know which one they're talking about, and it can be very misleading. Okay? And for us, type A personalities, anxiety producing. Okay, just like, what? I gotta change the lab I plan to do like next week. Oh my God, what am I gonna do? Okay, so yeah, it's important to have that communication. All right, something we didn't talk about last week yet is these kind of compounds. Okay, this is still a binary ionic compound like the ones you learned how to name last year, but it involves what we call a polyatomic ion. So if you guys take out your periodic table, okay, you will see at the top this table right here. Okay, the table of common polyatomic ions. Polyatomic means many atoms. Okay, so these are charged particles that are made up of more than one element. Okay. The naming for compounds that involve these are the same as the rules for naming other ionic compounds because they're ions. Okay, they are polyatomic ions, but they are still ions. All right, so we still name them in the same way with one change. We do not change the endings to "ide." Okay, we write them exactly as they appear on that table. All right, so if I had, for example, this compound, okay, how would I know that I would need to look at my table of polyatomic ions to name that.
The amount of elements in the compound.
Exactly, there's more than 2 elements, okay? If there's more than 2 elements and it starts with a metal, then I'm gonna have to name it with a polyatomic ion. In fact, I'm going to have to find what part of it is a polyatomic ion. All right, so I see lithium is a metal, so I know that's not it. That means this part here must be the polyatomic ion, okay? So I go over to my chart and I find NO3, okay? It's right here, and I see that its name is nitrate. So that stuff would be lithium nitrate, simple as that, okay? Okay, what would this stuff be called?
Calcium hydroxide.
That stuff would be calcium hydroxide. Okay, so again, what I did is I look at the compound and I see that there, sorry, that's supposed to be an A. Okay, that calcium is in it. Calcium is a metal, so I'm going to write the name of the metal as I would in any ionic compound. And then I can see there's more than one element here, so I go to my chart, I find OH, and I find that its name is hydroxide. Okay, because this is an ionic compound, I don't put any prefixes in. Okay, now, what are the brackets for?
That's to tell you that there's 2 of those compounds instead of 2 hydrogens.
Exactly. It's to tell me that there are 2 hydroxides. If I wrote it without brackets, like this, the math of that compound is different. Okay? This compound has 1 calcium, 2 oxygens, and 2 hydrogens in it. This compound, which doesn't exist, has 1 calcium, 1 oxygen, and 2 hydrogens. That's different. Okay, we use brackets sometimes around polyatomic ions when we drop and swap. If we have to put a number beside the ion, we put brackets around it so that we know, just like in math, this number applies to everything in the brackets. Okay? Everybody all right with that idea? Okay, now here's the one that's weird. There's only one, okay, in your table. What would that stuff be called?
Ammonium.
Ammonium,
Oh, chloride.
ammonium chloride. Okay, this stuff would be ammonium chloride. Okay, NH4 is a polyatomic ammonium, what, spelled? Not ammonia, ammonium chloride. Okay, so NH4 is a polyatomic ion called ammonium. It is the only one on your chart that is positive in charge. Okay, if you look at all the other ones in your table of polyatomic ions are negatively charged. So, that's the only one that acts like a what? Like a metal. Okay, ammonium is your only polyatomic ion that behaves as a metal. Okay, it has a positive charge, it gives up an electron, okay, so it behaves as a metal. Okay, it throws people off though because they see a non-metal listed first and they go right to, oh, it's a molecular compound because it's got a non-metal listed first. Okay, we got to watch out for that one particular polyatomic ion. It's the one that throws people off most. All right, is that making some sense? Okay. I would like you guys to try the first 4 here. Okay? All right, so for our first one here, okay, if we're doing one of these, I would first just follow the basic rules and write the metal and the non-metal ending in "ide." So I would simply write out, okay, this stuff is iron, this stuff is oxide, and then I would look at my periodic table and see that iron can be a 2 or a 3, okay, and then I would go back to find what charge it would be using the non-metal, okay, because the non-metals only have one possible charge. I know that oxygen is a -2, and I have 3 oxygens, so I have how many negative charges here?
Six.
6, yeah, I've got 6 negative charges in total. Each oxygen is -2, and there are 3 of them. That since this compound, and all ionic compounds, have to have an overall charge of 0, I know I've got to get 6 positive charges from the 2 iron ions that I have there. So 6 divided by 2 tells me this is iron 3. Okay, so we just do a little math, okay, and we get her done. Now, sometimes at this point, people look at this and they go, well, Coderre, all I would have to do is reverse the drop and swap, and I would get that answer. That will work about 2/3 of the time. There are going to be ones we run into where we've reduced the numbers because we could, okay, and we do that in ionic compounds, and if I reverse the drop and swap, I won't get the right charge, and that's about 1/3 of the ones we would do. So we don't want to just go, oh, I'll just reverse the drop and swap and I'll get the number. It's not going to work enough for that to be a good idea.
I'm a bit confused on how, like, we got 3.
How we got the 3? Okay, so what we do is we always look at our non-metals, because we can't look to iron. We know it could be a 2 or a 3, so it doesn't help me get to iron's charge. But since oxygen is always -2, I can use it to figure out how many negative charges there are in the compound. Okay? How do I do that? So I write down oxygen's charge, right? We know that everything in group 16 is a -2. Okay? Oh, you didn't write? Okay, so that's probably why you were confused. Okay, so yeah, guys, remember on Friday we talked about this and we said the charges for our non-metals are everything in group 17 is a -1. Okay, everything in group 16 is a -2, and everything in group 15 is a -3. Definitely need to know that. Yeah, this is going to be really hard. Okay, because then you're just guessing. Yeah. Does that make more sense? Okay, so all right. Let's have a look at number 2. So what does CO stand for? Cobalt. Okay. All right, what does that stand for? Sulfur. So we're going to write it as sulfide. Okay, and cobalt can be a 2 or a 3 as well, right? Yeah. All right, so I've got to figure out which one it is. What's the charge on sulfur? -2. Well, since they're 1 to 1, what's the charge on cobalt? 2. Yeah, +2. Okay, and all I did, guys, was go, yep, this is a -2, so that has to be a +2. I don't have to do any math there, okay, whatever, because they're 1 to 1, they have to have the same charge. So this is cobalt, Roman numeral 2, sulfide. Okay, for number 3, what does Mn stand for? Manganese. Okay. All right, and Cl? Chloride. Right. Okay, so manganese can be like a 3 or a 4, right? 2 or a 4. 2 or 4. So in this one, I look to my non-metal. Chlorine always has a charge of -1 because it's in group 17. There are 4 chlorines, which gives me how many negative charges?
4.
Right, -4. So what's the charge on the only manganese atom I have? 4. +4. So manganese, IV, chloride. Okay, and then for number 4, Cu stands for? Copper. Okay, S, because we already did it, is sulfide. Okay, and if sulfur is a -2, the copper's got to be +2. So copper 2 sulfide. Okay. How are we feeling about that? I mean, you got to flex your math muscles a little tiny bit, okay, but it's not too difficult. All right, let's have you guys try down to number 10 here. I think I don't have any polyatomics in there. Yeah. Okay, for number 6, Hg stands for Mercury. Okay, if you ever see a symbol that doesn't seem to make sense with the element's name, it's because it was originally in Latin. Okay, it's like hydruntium or something like that, basically liquid silver. Like hydro means liquid and argentum means silver, so hydrogentum. Okay, is mercury, quicksilver. Okay, and then At is astatine, so that would be mercury astatide. Okay, and astatine is in group 17. Okay, everything in group 17 is in -1. All right, so since there are 2 astatines and each one is -1, I have a total of 2 negative charges. I only have 1 mercury, so its charge must be positive 2. Mercury, 2 astatine.
Sorry to interrupt, but I still don't get that.
Okay, so the math goes like this. I look up what charge is on the nonmetal, okay, and I just write it up here. And then I multiply that number by any subscript number. Okay, if every astatine has a -1 charge, and this compound has 2 of them in it, then there are 2 times -1 negative charges.
Okay.
Yeah?
Now I understand.
Okay. All right, for number 7, PO is polonium. Okay, and it's got a weird charge, isn't it? It can be, ooh, I lost it. There it is. Negative, or +2 or +4. Okay, so it can be +2 or +4, okay? And iodine is always a -1 because it's, again, in group 17. All right, so I'm going to write that this is polonium, something, iodide, and then I'll figure out the something. Okay, there are 4 iodines. Each iodine is a -1 charge, giving me a total of 4 negative charges. There's only 1 polonium to balance those 4 negatives out, so this is the polonium with the 4+ charge. Question? Nope, sorry, stop that thing going up. Okay, number 8, we got Sb, which is antimony. I don't remember what the Latin name for that is. Okay, antimony, and it can be a +3 or a +5. Okay, so we're going to write antimony. Okay, and then something sulfide. Okay, what's the charge on sulfur all the time? -2. Okay, so every sulfur is -2. There are 3 sulfurs in here for a total of 6 negative charges. -2 times 3. Okay, now I've got to get 6 positive charges out of the antimony, and there are 2 of them to help me do that. 6 divided by 2 is 3. Okay, so this would be the antimony, Roman numeral 3, sulfide. Okay. Other than having a polyatomic ion in them, that's about as tricky as they get. Okay. All right, number 9. Ni stands for nickel. Okay, and nickel can be a 2 or a 3 if memory serves. Okay, and N is nitrogen, so it's going to be nickel something nitride. Okay, what's the charge always on nitrogen? -3. It's in group 15. Okay, so every nitrogen has 3 negative charges. There are 2 nitrogens there, giving me a total of 6 negative charges. So I've got to get 6 positive charges out of the 3 nickel ions that I have. 6 divided by 3 is 2. So this is the nickel 2 nitride. Okay. All right, and then number 10, Bi stands for bismuth. Okay, so this is going to be bismuth. Okay, something oxide. Okay, what are the possible charges for bismuth?
3 and 5.
3 and 5. Okay, so let's have a look at our oxygen here. Oxygen's always -2. Okay, how many oxygens do I have? 5. How many negative charges do I have? 10. Okay, so I've got 10 negatives. That means I've got to get 10 positives from the 2 bismuth ions I have. 10 divided by 2 is 5. This is bismuth V oxide. Okay, is that making some sense? Here's what people mess up on this. They don't forget how to do that. They forget to do that. Okay, they just write out the name and they forget to do the Roman numerals entirely. Or they over-apply it and they do it to everything. Okay, do I need to do this to every ionic compound? No. Only ones that contain 2 or more charges, transition metals. Okay, just whatever is going to make more sense in your head. Remember, you don't do this on every ionic compound. You only do it when necessary. Okay, that's when it gets tricky. When I throw up a list that's got ionic compounds, some that need Roman numerals, some that don't, that's when the gears have to get moving. Okay? All right. No, I don't have any there. Okay. Where was the one I wanted? Before we get to molecular. Okay, we'll do the molecular first because that list has everything in it. All right, let's talk molecular compounds here. Okay, with molecular compounds, okay, the naming is going to involve prefixes. Okay, and the reason for that is, unlike ionic compounds where electrons get traded, the molecular compounds share their electrons. So there's not really a rhyme or reason to how many oxygens can go with a nitrogen atom. Okay? There could be 2 oxygens and 3 nitrogens. There could be 3 nitrogens and 2 oxygens. There could be 1 of each. It completely depends how they want to share the electrons. Okay? So, since there's more than one way that nitrogen and oxygen can go together, when I write out the name, I have to say there's this many nitrogens by using a prefix, and there's this many oxygens by using an appropriate prefix. Okay? I don't have to do that with ionic compounds because in trading electrons, there's a certain ratio that lithium and chlorine can go together in. Okay? Everybody all right with that idea? Okay, so where with the ionic compounds, it's like, okay, I got my electron, or I got rid of my electron, thanks so much, I never want to see you again. Okay, that kind of relationship with the ions, with that bond being very weak. Okay, with the covalent bonds, or the ones that molecular compounds have, because they're sharing those electrons, they cannot let go. Okay, they will be incomplete without the other. Okay, so these bonds are incredibly strong, which causes molecular compounds to have very different properties than ionic compounds do. They behave very differently, okay? And that's simply because of how or what they do with their electrons, okay? And that is that they share them and they hang on very tightly to each other, okay? So really all you need to know in terms of molecular compounds is they're made of 2 nonmetals, the electrons are shared, and the bonds are very strong. Okay, that's kind of the basic gist of how a molecular compound works. Okay, so molecular compounds are 2 or more nonmetals. Okay, electrons are shared. Okay, and I don't think it says in there anywhere, but the bonds are very strong. Okay, so the naming rules are fairly straightforward. Okay, whatever nonmetal is first, we just write the name of it. We don't change it at all. Okay, whatever nonmetal is second gets its ending changed to "ide," just like anything else. Okay, the second one gets its ending changed to "ide." Okay, so and then of course we would use prefixes. So for our first one here, okay, we have 1 carbon and 2 sulfurs. So this would be carbon disulfide. Okay. For our second one, okay, we've got 2 nitrogens and 1 oxygen. So we would say that this is dinitrogen, di meaning 2, okay? And actually that's wrong. I forgot to change that. Dinitrogen, what should go in front of the, or dinitrogen, what should go in front of the oxide? Mono, yeah. Okay, dinitrogen monoxide. Why didn't I put a mono here? Don't need to for the first one, because reasons, I guess. Chemistry has to make weird rules for whatever reason, I don't know. Okay? Seems like if you're going to have a rule, it should just apply to everything, but not in this case. You never use mono on the first one. Okay? Mono only ever gets used on the second one, if applicable. Okay? All the other prefixes can get used on the first one. I don't know. It's just the way chemistry works. Okay, and then this one here, okay, I have how many phosphorus here? Okay, how many oxygen? Okay, so prefix for 4 is tetra. Okay, so tetraphosphorus, decaoxide. All right, here is something you can write on your periodic table. The prefixes from 1 to 10. Okay, there are your prefixes from 1 to 10. Okay, so 1 is mono, 2 is di, 3 is tri, 4 is tetra. It's basically like geometry. Okay, 5 is penta, 6 is hexa, 7 is hepta. Don't say septa. It's very triggering to Mr. Real. Okay, I don't know why. Okay, septa is triggering for Mr. Real, so say hepta. Okay, 8 is octa, 9 is nona, 10 is deca. Okay, so this compound, or no, actually, this molecule, it's not a compound, okay? This molecule here has 2 hydrogens. Why is it only called hydrogen? Why isn't it called dihydrogen?
Can hydrogen like not exist without having to?
Yeah, it always comes as a pair, okay? And it's only got what in it?
It only has hydrogen and a diatom, because it's too unstable to stay by itself.
It's diatomic.
Yeah.
Okay, some elements bond with themselves. We call them the molecular elements because they don't come as a single atom, they come as a molecule. We don't name them, we don't use any prefixes on them because they're not a compound. They might be a molecule, but they're a molecule that only has one kind of atom in it. Okay, so this is molecular hydrogen. This is molecular oxygen, molecular nitrogen, molecular chlorine. There are a whole bunch of elements on the periodic table that are molecular elements. Okay, now they all make kind of a 7 right here. Starting with nitrogen, go over and down. All of those are diatomic. They come as a 2. Okay, nitrogen, oxygen, okay, fluorine, chlorine, bromine, iodine, aspartame, okay, all of those come as a 2 when they're by themselves. They're what we call molecular elements.
So, should we
Yeah, I'll let you kind of mark on your periodic table that those are our special elements, okay? Because it will be important when we get to reactions. Okay?
Is it the non-metals that are diatomic? Or is
Well, mostly non-metals, one pseudo. Okay, we'll get to it. So those ones there, okay, in kind of the 7, okay, and then in the hook or armpit of the 7, so right in here, these two are also molecular, but phosphorus comes as a 4, a molecule made of 4 phosphorus atoms. Sulfur is an octet. It comes as a molecule made of 8 sulfur atoms. Okay, so you got N2, O2, F2, Cl2, I2, At2, okay? Then you've got P4, S8, and one more, hydrogen, way over on the other side, okay? Always comes as a 2, when it's by itself, okay, when they're elemental.
Wait, sorry, which ones are all the diatomic?
Okay, so these ones are the diatomic ones, okay, from nitrogen over and down.
Okay.
Phosphorus is a 4, sulfur an 8, hydrogen a 2. All right, let's have you try the first 4 there. Okay, I'd like the names of those molecular compounds. Nitrogen. Okay, so we're gonna have nitrogen. Okay, do I need a prefix on that?
No.
No. Okay, and then what does I stand for? Iodide. How many are there? Tri, right, 3. So tri, and guys, I don't care if you do this or not, but I think technically, because there's 2 vowels there, you need a hyphen. If you don't have a hyphen, I don't care. I don't teach English. Okay, so something like that. Nitrogen triiodide. All right, number 2, what does C stand for? Carbon. Okay, there's only 1 carbon. Do I need a prefix?
No.
Okay, what prefix do I need on the iodine? Tetra. Okay, so carbon tetraiodide. Okay, N is nitrogen. What prefix do I need in front of it? Di. So dinitrogen trioxide. Okay, that probably should have a hyphen too. Something like that. Okay, and then for number 4, okay, how many tellurium do I have? 1. Okay, so I don't need a prefix there, so I'll have tellurium diacetyl.
Oh, I said it wrong.
Acetyl, yeah, so. All right. Everybody okay with that? Pretty straightforward? Ringing a bell? You're not gonna get any new rules for molecular, okay? The rules you learned last year for molecular are as complex as molecular gets, okay? We're only gonna have binary molecular compounds. All right, try up to number 10 there, and then we'll throw a mix and see how we do. Okay, what would the name of number 5 be? Right, diphosphorus trisulfide, right? We have 2 phosphorus, so we use that prefix, diphosphorus. Okay, and then there are 3 sulfurs, so trisulfide. Second one has to end in I. Okay, what would number 6 be? Oxygen monosulfide. Right, the first one doesn't get a prefix if it's mono, but the second one does. Okay, and then for number 7, what would we have that called? Right, trisilicone tetraphosphide. Okay, number 8. Sulfur dichloride. Yep, we don't put a mono on the first one, so just sulfur dichloride. All right, and then for number 9,
silicon on tetrahydride.
Tetrahydride, right. Okay, and number 10?
Tetrafluoride.
Try Carbide, yeah.
Carbide, yeah.
Okay, tetraboron. Tricarbide. Okay. So the challenge here is when you have a compound and you're not told, hey, everything in this list of 10 compounds is a molecular compound, apply the molecular compound naming rules. Okay? The challenge comes when you just have a compound and you have to decide, is this molecular, is this ionic, what rules do I use? Okay? That's where the challenge comes in. So how can I tell right off the bat whether something is ionic or molecular?
If there's a metal.
Right, if there's a metal, listed first, okay? Because hydrogen could be listed second, but yeah, if there's a metal in it, generally, it's gonna be ionic. Then I would use the ionic rules. If I'm using the ionic rules, what do I have to check for?
Multiple charges.
Right, multivalent metals that might have multiple charges. If I have one of those, what do I put in? Roman numerals. Okay. What if I have one of like a metal and then I've got like two non-metals in a group together? Then I use the polyatomic ion naming. Okay? So little things to watch for, because when we get a group that's all a mix, okay, then we've got to go, okay, that's ionic, I follow these rules, I got to look for this, I got to do this. This is molecular, I got to do this and this. Okay? That's where the challenge comes in. All right. There is the challenge. You have 15. Okay? Some are molecular, some are ionic, some need Roman numerals, some have polyatomic ions. It's a little of everything. Okay? Let's see how we do. I'll give you a few minutes and then we'll do like the first 7. And then I'll give you a few more minutes and we'll do the other ones. Okay? You guys have them all up here, so we'll write them down and give them a try. Okay? If you're having trouble, let me know. I'll come around and help. All right. So number 1, ionic or molecular? Ionic. Lithium is a metal. Okay, so I follow the ionic naming rules. This stuff will be lithium chloride. Okay, no prefixes, no Roman numeral required either, because lithium is always a +1 and has no other charge. Okay, number 2. Ionic or molecular? Ionic. Chromium is a metal. Is it a special metal? It is. Okay, it has more than one charge. 2 or 4, I think, right? 2 or 3 or 2. Okay. All right, so we got chromium, okay, and it is a multivalent, so I'm just going to write chromium fluoride to start with, and just leave a space for that Roman numeral. All right, fluorine is in group 17. Everything in group 17 is a -1. I have 3 fluorines, so I have 3 negative charges. Okay, I've got to get 3 positive charges, and I only have 1 chromium to get them from, so Roman numeral 3, that's chromium with the 3+ charge. Okay. All right, so as I'm talking through it, guys, these are the steps that you need to kind of think through as you're doing one of these. Okay, I'm just kind of verbalizing them so you hear them. All right, number 3, ionic or molecular?
Molecular.
It's molecular. They're both non-metals this time. Okay, so what's P stand for?
Phosphorus.
Okay. Okay, does it need a prefix?
No.
Okay, what about bromine?
Yes.
Which prefix?
Try.
Okay, phosphorus tribromide. Number 4, ionic or molecular? Ionic. Zinc is a metal. Okay, is it a special metal? No, it only has 1 possible charge. Zinc is always a +2, so I don't need a Roman numeral. I can just follow the ionic naming rules. I write the metal, I write the non-metal. I end it in "ide", no prefixes because it's ionic, and I'm done. Okay. All right, number 5, ionic or molecular?
Molecular.
It's molecular, both are non-metals, okay? So do I need a prefix on silicon? Okay, which one do I need on the oxygen?
Die.
Do I always need a prefix on the second element?
Yes.
Yes. Okay, even if it's mono. Mono is the only one that doesn't go on the first. Okay, number 6, ionic or molecular? Molecular. Carbon's a non-metal. Okay, so it doesn't need a prefix because it's a single and it's first. What prefix goes on sulfur? Tetra. Okay, number 7, ionic or molecular.
I
Right, technetium is a metal, okay? So, okay, and what prefix am I putting on the iodine?
You're not.
Good, okay. Technetium iodide, okay? I don't think that one needs a Roman numeral because it's a +7.
Yeah, it's +7.
Yeah, it's only +7, yeah. Okay, and incidentally, technetium is also an element that does not exist in nature. It's only produced in the lab. Yeah, it's one of the weird man-made ones. Okay, all right, how many people are done past number 10? Okay, we'll give you a few more minutes to finish that up because we got a few, we got a short class. See? Okay, 9:50, right?
Yeah.
Okay, all right, let's have a look at a couple of the ones here that have the polyatomic ions in them, just so we get them done. Okay, number 8, ionic or molecular?
Ionic.
Okay, and I know that for 2 reasons. It has a metal in it, best reason, and it has a polyatomic ion in it. If you have a polyatomic ion, it has to be an ionic compound. Okay, so I would write the name of the metal, sodium, and hydroxide. Okay, what about number 9? Ionic calcium sulfate. Right, now I put brackets around that. Did I need them? No, I didn't have another number out there, but it isn't wrong to enclose ion or polyatomic ions in brackets, even if you don't have a number. It's not wrong, it's just also not necessary. Okay, you just wouldn't get it marked wrong. All right, we will leave it there for today, okay, and we will do the other ones tomorrow. Just a note, okay, you do have a quiz this Friday, okay? The practice quizzes, if you're looking to do a little practice that you would want to use from Google Classroom, are chemistry quizzes 1 and 2. Some of the stuff in 2 we haven't gone over yet, okay? So don't panic if you're looking at that quiz and like, oh, I don't know how to do this. We'll be doing that this week, okay? But we have definitely done everything you need in quiz number 1. Okay, or you'll already know how to do some of the other stuff from last year. Okay, so through the week, if you want to do a few practice quizzes, you can open those up in Google Classroom. It's a PDF. Try the questions, and there's also a link in that playlist, okay, to the quiz answers. So if you click in the playlist, take you to YouTube, you click on chemistry quiz number 1, it's like a 5-minute video, okay, and it's the solutions. So you can check your answers. If you're struggling, come see me for help. I'm here all the time because I have no life. Okay, come and get help if you need it. All right, why don't you guys grab your phones? Dave, fella's going to go here right away.